Hi everyone, welcome to another maths video by Maths with Sarah. So today we're going to be taking a look at this shape question where it asks you about two similar shapes. So B is an enlargement of shape A with a scale factor of 1.5. And there are various values or lengths and angles that are known in one of the shapes and some that are unknown as well. We've been asked to work out all of the unknown values. So W here, X and H. Now, if you're comfortable with enlargement and scale factors, then this shouldn't be too difficult, but definitely with a scale factor of 1.5, it just makes it a little bit of a challenge. And because of the ways that you've got to work things through, you've got to work forwards and backwards, just a little bit of a tricky one. So as with all these questions, I really encourage you to pause the video and have a go yourself before I get started on working it through. And this will give you a chance to have a think about how you would do it. Even if you can't work all the way to the answer, it's a really good idea to have a think about the first, maybe even if just the first step that you would do, or what method you might use, or how you would even approach this question. Okay, so let's get started. We have been told that A and B are similar shapes. Now, the first part of this question that we need to make sure we understand is the definition of similar in a mathematical sense. So a mathematically similar shape is one that essentially the shape is the same, it's just a bit bigger or a little bit smaller than the other one. So the proportions are all exactly the same. So it's not identical in the sense that would be congruent if they're exactly the same, if they've got all the same dimensions. These are similar, which means the dimensions are different, but just because one is bigger than the other. So that's what we mean by similar here. And it says that B is an enlargement. So that again just means like one's a bit bigger than the other with a scale factor of 1.5. So this means that B or shape B is 1.5 times bigger than A. Okay, and then we've been given the value of this side length as 5 centimeters. We've given the angle 54 degrees, and we've been given W on shape A, and then we've got H and X on shape B, and we've been told that this side length here is 9 centimeters. We've been asked to work out these three unknown values of X, H, and W. Okay, so let's start with the angle. So the angle is actually probably the simplest in this question because when we have similar shapes, the angles are always the same. And this is literally, as you can see just by looking at it, I know that it says that it's not drawn accurately, but just by looking at them, you can see that this angle is going to be pretty similar. So just because the side lengths are changing, the actual angles are not changing at all. So the angle X would just be 54 degrees. And you can try this if you don't believe me, try drawing these out actually to scale, or even try drawing, if you think about a couple of rectangles or something, or say we've got a triangle. Actually, no, let's do, so if we've got a rectangle, and we make that rectangle however much bigger, the angles are still all going to be 90 degrees. So just because the rectangle is that much bigger, we've both got the same slanty top there as well. Just because the rectangle is that much bigger, the angles actually aren't changing, they're all still 90 degrees. Same for a square or whatever other shape you're looking at. So that's a really good way of just remembering that this is what happens when we've got similar shapes. So we've got 54 degrees in this one, and this one is also 54 degrees. And that's not going to change no matter how many times we enlarge this shape. If we made it 1,000 times bigger, although the length and the width would all change, so all of these dimensions would all change, the angles will not change at all. Okay, so the next one that probably the next easiest to work out will be H. So we've been given 5 centimeters here. We know that this length here, because this shape is 1.5 times bigger, which means this side length will be 1.5 times bigger. So to work out what H is equal to, we need to do 5 centimeters times by the scale factor of 1.5, and that will give us our answer for H. So if you do that maths, you do 5 times 1.5, you end up with 7.5 centimeters. So I'm always a firm believer in just stopping at the end of, when you get to the end of the question, just pausing for a minute and thinking, does the answer that I've got make sense? So we've started with 5, we've ended with 7.5. Yep, that's very reasonable. We've got a side length of 7.5 here, and we've got a side length of 9 centimeters here. Both of those seem very similar. It seems logical that could be the right answer. if we'd got 750 here, hopefully you would be questioning and thinking, hold on a minute, I think I might have made a mistake. But that's why I just like to stop here and just have a little chat just to make sure that we've not done anything really crazy in the answer. Okay, so the next one that we're looking at is we've got W here. So with this one, we said that if we were going from shape A to shape B, because it was 1.5 times bigger, we had to multiply it by 1.5. So if we've got a value in shape B, i.e. this 9 centimetres, and we want to go backwards from shape B to shape A, we need to do the opposite. So to go from B to A, we need to do the opposite of this. So whereas we times by 1.5 to go from the small A to B, we need to divide by 1.5, i.e. do completely the opposite to go from B to A. So if we go back to the shape, we've got 9 centimetres here, and we want to know what W is. Again, we're going backwards, we're going from B to A, so we're going from the bigger shape to the smaller shape. It means we need to divide by 1.5 scale factor. Okay, so if we do 9 divided by 1.5, we end up with 6 centimetres. So again, just want to pause and think here, just stop here for a second and think, have we got roughly the value that we're expecting? So we know that shape B is bigger than shape A, which means we're expecting a smaller value. So that's a tick. Yes, we have got a smaller value. We started with 9, we've ended with 6. That's all good. And then we know that this one is slightly small. So 7.5 centimetres at this length is slightly smaller than this side one. So we're expecting the value of this slanting side to be slightly bigger than this vertical side. Again, tick, we've got it, and it's roughly similar, a bit smaller than 9, a little bit bigger than 5. We're in the right ballpark area. We haven't got a 600 or 6,000, which, you know, if you type this into your calculator wrong, you might have got something completely off the wall. So this is where it's really good to just stop and have a very, it literally takes like a second to just think, does this make sense? Yes, my answer does make sense. So you can, although you can't guarantee you've got it right, you can at least think, actually, yeah, I've obviously done something reasonable here, and you've got all your working out written on the diagram, which means that if you have got it wrong, at least somebody can see what you were trying to do, and hopefully you'll get at least a few marks. But I can't remember how many marks this question. I think it was either 2 or 3 marks. Hopefully you'd at least get a few marks for, I've noticed it must have been at least 3 actually, because you've got 3 different unknowns. Hopefully you would definitely get some marks for putting all your workings out on here. Okay, so hopefully that all made sense. I've got quite a lot of different shape videos and definitely some which involve scale factors. So somewhere we're taking this a little bit further and looking at areas and volumes using scale factors. So if this is something where you want to challenge yourself a little bit, then I encourage you to check that one out. I'll tag it in the top corner. And I've also got plenty of other shape questions as well. So if this was a bit of a challenge, maybe have a look at some of those other ones, and I'll again tag those in this video so that you can look at some that are maybe around the same level as this, just to kind of solidify what you've learned in this one. Okay, hopefully see you soon for another video with Maths with Sarah.